Back to our main driver program. All of this should be now operational. We should be able to see the the effects of us working with this. What we can do is we can insert some tracing statements, right? So what we can do here is that we can go to the top of our file, right, and say include. This is inside instack.cpp, implementation file for the stack. Include IO string. Okay, and I can now insert some trace messages into allocate memory and reallocate memory, right? So what I can do std cout display. We can display. There is a preprocessor symbol that you can use to visualize your functions. Underscore, underscore, two underscores. Function. Again, underscore, underscore. Oops. Underscore, underscore. Function. Okay, so there's this preprocessor symbol which basically knows the name of the current function so that it helps in debugging. And we can say function, and we can just basically print size equals, right? Size equals, and just print whatever the block size is. Right? So as we move along through our runtime execution, we will be printing the name of the function in the size of the actual allocation of dynamic memory, right? And then similar statement we can insert into reallocate memory. And by the way, sometimes it's helpful to position these statements towards the end of your function, because sometimes if the function crashes for some reason, you may see or not see the trace message, right? And I would typically also clearly mark it as this is debug, right, for debugging purposes. So likewise, the similar statement, cout function size equals block size. Similar statement we can place inside reallocate memory. Okay, and so now we have this this entire arrangement of allocation, reallocations, and as we move through this program, let's build this, right? So let me push this to the next tab group so that you can see what I just did, right? So it was this statement that I inserted, right? This trace statement that I inserted, and I just built it. Oh, it actually didn't like something missing, missing semicolon. Oh, that's the usual thing, right? Just forgot to place the semicolon right next to the reallocate memory call. All right, so there we go. We have those two trace statements now, and once again build and run it. So properties, whatever, just pick the color, right, and then make it more visible. That'll do, and usually turn on quick edit mode so you can easily copy and paste from there. So it's a little bit messy, so of course I forgot to insert the new lines. Obviously in my trace statements I also would like to insert the new line, something like that, new line, and add it to all of these tracing statements. So new line at the end of these debugging statements. Build it again, run it. So you see, initially we say allocate memory and the size is 1 because that's what the default says, right? My default size is still set to 1, right? So then what happens is that the first time we push, it's okay, but the next time we push, it notices that there's not enough space, so we double the capacity, so now we have a block of 2 integers. Then we insert the third element, and now again there's a shortage of dynamic memory available, so we switch over to 2, and we still top of the stack is still 2. An interesting thing is the capacity is now 4, but the size of stack is 2, because so far what I was doing is that I have 1 pop, which reduces the number of elements by 1, right? And then when I print the size, obviously it says you have 2 elements, and the element number the integer 22 is at the top of the stack. Next thing I would like to go over today is that typically when you have a program like this, just the main function that uses memory, uses the stack and does something, it's a small little toy program that essentially trying to experiment with the concept of the stack. But if I wanted to go into the real world with the stack, what I also need is that every time this object goes out of scope, destroyed, perhaps I should take care of this memory. And today I would like to introduce to you this new idea of array. Array stands for resource allocation is initialization. Resource allocation is initialization. What it means is this. If you think about our int stack, right? Int stack, it's of course is an object which we create at runtime. Somehow we find a way to create an object. Perhaps we just declare an object and start using it. But in reality, this object has multiple means to manage that dynamic block of memory where we, basically store the actual data. So the way we can manage it is this. When we just create the stack, we create the initial size. We know that if the initial size was too small, we can obviously grow this dynamically to a bigger size, and so forth. But also, when this object goes out of scope, gets destroyed, right? So it basically, this object is disappears, goes out of scope. What needs to happen that we need to say delete. Delete this thing to return memory back to the system. We don't want to retain this dynamically allocated memory. And this is where this array principle comes in. It says your constructors should initially claim memory, allocate memory, but when the object goes away, it should return the memory, right? So initialization is when you first claim memory, and when you do deallocation, this array principle presumes that before this object disappears and goes away, it needs to deallocate memory that it is currently allocating. How can we do this? Very simple, actually. As you can have constructors, you can also have a destructor in C++. In Java, destructors are not available because you have a special Java virtual machine thread which executes destructors on your behalf and returns memory automatically. This is why Java is considered to be managed memory environment and is praised so highly, so that it makes it easier and nicer and simpler to use dynamic memory. Anytime object is created as new in Java, and then by the time your program does different things, the runtime environment is smart enough to realize that this specific object is no longer being used, so it can be garbage collected and safely the memory is returned. In C++, we have to make an extra step and add a destructor. Destructor has exact same signature as the constructor, except it has the tilde symbol in front of it, right? So the tilde is this. Right, and the same signature as your default constructor. Okay, so this is called the destructor, number one. Number two, of course, we need to essentially create its implementation. So just as always, I copy the name of the function, which now includes this tilde. And by the way, tilde is used because tilde is actually a bitwise operator that you can use on your integer values, which actually flips all bits. And it's called the complement operator, okay? But it's being used in C++ as part of the destructor, which you can see is like a complement to the constructor. So just as you can have the constructor, the destructor uses the tilde in its name. Control C and go to the implementation, which would be somewhere I need to pick. I usually place my destructors next to the constructor. And by the way, if you can have multiple constructors, you can have only one destructor in a class. It is simply invoked for us as soon as the object goes out of scope. So the usual procedure is to copy the if you'd like to type it in, that's your choice. But then, of course, you need to prefix its name like that, right? And of course, get rid of the semicolon and instead provide the function body, right? So this is the definition for the constructor, and this is the prototype. I'm sorry, destructor. This is the definition of our destructor, and this is the prototype or declaration of our destructor inside the class in stack. And what it's supposed to do, simply say delete this memory block, right? So the memory block always remembers, and we need to use basically the square bracket notation, because if the square brackets were used when we did the initial memory allocation like this by new, delete is the opposite of new, and delete says to the memory manager, hey, we're done, we no longer need this memory, you can take it back, okay? And that's the syntax for it. Of course, in C, in the suggested textbook, you can see the malloc, which is the allocation, the raw style of allocation of memory bytes, and free, which is the allocation of your block of memory in C using the C library functions. But in C++, the free store memory manager is managed by saying new and delete. Okay, so that concludes pretty much our today's set of experimentation with this stack. Before we run out, let's just make sure that we can build everything, that the syntax is still okay, and just make sure that we run it and that we can see what it does. So it does exactly the same thing, but before the stack disappears, of course, the memory will be returned back to the system, and that's what we want with resource managers such as the stack, because we have an object right here, right? So our object right here is basically something that manages system resources. Memory is system resources, therefore it has to be allocated properly and deallocated properly. And this principle, RIE principle, which is resource allocation is initialization, we will discuss more about it in the future, but today our first look at this is that we actually assume responsibility for both allocation and deallocation, and we effectively trying to use constructor and destructor to do something like this. More on this story next week. We're actually going to find out that we have some problems with the current implementation, and it's not completely safe, and we will discuss issues with it, and we will obviously continue with version 3 of this tech class, but I choose to demonstrate that some of these principles, and hopefully you enjoyed today's set of presentations where you can see how things are happening at the lowest level. Just remember that things such as new and delete and those, counting of integers in memory is perhaps as low as you can go, right? So most of the time you don't write code like this every day, but occasionally you need to be able to go to these lowest levels and be able to deal with this type of code. So thank you very much. See you guys next week.